Okay, so before we jump on to the IAM part, the identity and access management, let's go through the overview of AWS. Okay, so one of the key benefits of cloud computing is the opportunity to replace the upfront capital infrastructure expenses with the low variable costs. Okay, so with the cloud, businesses no longer need to plan for and procure servers and other IT infrastructure weeks or months in advance. Instead, they can simply spin up hundreds of thousands of servers in minutes and deliver results faster. Okay. So today, AWS provides a highly reliable, scalable, and low-cost infrastructure platform in the cloud that powers hundreds of thousands of businesses in more than 190 countries around the world. So at its core, AWS provides the on-demand delivery of IT resources via the internet on a secure cloud services platform, offering compute, storage, databases, content delivery, and other functionalities to help businesses scale and grow. So using AWS resources instead of your own is like purchasing electricity from a power company instead of running your own generator, and it provides you the key advantages of cloud computing. So the capacity exactly matches your need. You pay only for what you use. Economies of scale result in lower cost, and the service is provided by a vendor experienced in running large-scale networks. Okay, so these are few services that you see on the screen, such as your Amazon EC2. Okay, so Amazon EC2 is a web service that provides resizable compute capacity in the cloud. So it is basically your infrastructure as a service, just like your virtual machines that you run in on premises. This is offered by AWS. Okay. Then we have our Amazon RDS. Okay, so Amazon RDS provides a fully managed relational database with support of many popular open source and commercial database engines. So it's a cost-effective service that allows organization to launch secure, highly available, fault-tolerant, production-ready databases in minutes. Okay. Then you have AWS Direct Connect, which basically allows the organizations to establish a dedicated network connecting from their data center to the AWS data center of their choice. Then we have Amazon EBS, okay, which provides the persistent block level storage volumes for use with your Amazon EC2 instances, that is your machines that you are deploying. Then we have Amazon S3, okay, which is a simple storage service from AWS, which provides the developers and the IT teams with highly durable and scalable object storage that handles virtually unlimited amounts of data and large numbers of concurrent users. Then we have elastic load balancing in order to distribute loads to your servers. Let's say if you have multiple web servers, we have Amazon elastic load balancing as well, which can be leveraged in your overall solution. Then you have services like Route 53, okay, which is again a highly available and scalable domain name system web service, which is designed to give developers and businesses an extremely reliable and cost-effective way to route end users to the internet applications by translating human readable names into the numeric IP addresses. For example, if you go to google.com, google.com will be having your corresponding IP address as well. So in a nutshell, there are a lot of many services other than that you see on the screen, and then to effectively govern and manage them, we need to know about the identity and access management part. Okay. So in cloud, identity and access management is often related to the role-based access control. Okay. So AWS provides you that particular facility, and apart from that, it has another offering which is slightly different from the RBAC. It is attribute-based access control. That is, you control only the attributes, grant the access on those respective resources that are required. That's it. So attribute-based access control, or ABAC, is an authorization strategy that defines permissions based on attributes. So in AWS, these attributes are called tags. And tags can be attached to the IAM principles, which are basically your users or the roles that you create, like a VM contributor role, okay, or a storage administrator, or any built-in role or a custom role that you have, and then assign that to the respective AWS resource who will be responsible to manage that or administer that resource. Okay, so you can create a single ABAC policy or a small set of policies for your IAM principles. So these ABAC policies can be designed to allow operations when the principles tag matches the resource tag. So ABAC is helpful in environments that are growing rapidly and helps with situations where policy management becomes cumbersome. For example, you can create 3 roles with access project tag key, okay, and then set the tag value to the first role to heart, okay, like you see on the screen over here. Then you can set the second to sun, okay, and the third to lightning. You can then use a single policy that allows access when the role and the resource tag with the same value for the access project. Okay, so access project is a hypothetical project name that I'm quoting here. So ABAC provides you the advantages over traditional RBAC model, such as ABAC permission scale with innovations. So it's no longer necessary for an administrator to update the existing policies to allow access to new resources. For example, assume that you designed your ABAC strategy with the access project tag. A developer uses the role with the access project. For example, on the screen that you see is a hard tag, the first tag that's there. Okay. When people on the hard project need additional EC2 resources, the developer can create new EC2 instance with the access project is equal to hard tag. Then anyone on the hard project can start and stop those instances because their tag value matches. Then second advantage of ABAC over RBAC is that ABAC requires fewer policies because you don't have to create different policies for different job functions. You create fewer policies in those scenarios. So those policies are easier to manage. Then the third advantage of ABAC over RBAC is that you can use ABAC in which teams can change and grow quickly because permissions for new resources are automatically granted based on the attributes. For example, if a company already supports the Heart and Sun projects using ABAC, it's easy to add a new Lightning project. So an IAM administrator creates a new role with the access project is equal to lightning tag. So it's not necessary to change the policy to support a new project. Anyone that has permissions to assume the role can create and view the instances tagged with the access project is equal to lightning. Then the fourth advantage is you can have granular permissions in ABAC. Okay, so when you create policies, it's best practice to grant least privileges or grant only those privileges that are required for a particular person to be able to use a resource. Then another advantage is that you can use employee attributes from your corporate directory with ABAC. So you can configure your SAML based or web identity provider to pass session tags to AWS. And then when your employees federate into AWS, their attributes are applied to the resulting principal in AWS. So you can use ABAC to allow or deny permissions based on those attributes. Okay, so that was just about the ABAC. Okay. Now, if I talk about the identity and access management service, it is a powerful service that would allow you to control how people and programs are allowed to manipulate your AWS infrastructure. So IAM uses your traditional identity concepts such as users, groups, and access control policies to control who can use your AWS account, what services and resources they can use, and how they can use them. So the control provided by IAM is granular enough to limit a single user to the ability to perform a single action on a specific resource from a specific IP address during a specific time window. So applications can be granted access to AWS resources, whether they are running on premises or in cloud. So this flexibility creates a very powerful system that will give you all the power you need to ensure that your AWS account users have the ability to meet your business needs while addressing all of the security concerns of your organization. Okay. So let's go ahead and see what we'll be studying further. like why do we use IAM, what is an IAM, why do we need IAM, how does IAM work, and the components and the features of IAM. Okay. So if I talk about the security, cloud security is the highest priority in AWS. When you host your environment in the cloud, you can be assured that it's hosted in a data center or in a network architecture that's built to meet the requirements of the most security sensitive organization. Additionally, this high level of security is available on a pay as you go basis, meaning there is no really upfront cost. And the cost for using the service is a lot cheaper as compared to an on premises environment. So there are many types of security services available, but some of them are widely used by AWS, such as your IAM. Then you have KMS, which is your key management system. You have Cognito. You have your web access firewall, that is your WAF. Okay. So IAM basically enables you to manage the access to AWS services and resources in a secure manner. Okay. So with IAM, you can create groups and allow those users or groups to access some servers, or you can deny them to access a particular service. Okay. So IAM becomes a critical part of your overall cloud security. Okay. So these are the various security pillars that you need to take care of. Okay. First being your identity and access management, like having only the required person or teams access the required resource. Then you have various controls that are there. Then you have infrastructure protection, you have data protection, and then an incident response team. Okay. So you have to cover all these 5 pillars in order to make your environment secure. Then why do we use IAM? Okay. So IAM helps protect against security breaches by allowing the administrators to automate numerous user account related tasks. So an identity access management system can also help track many of the auditable items required by industry policies and standards, such as access control implementation and monitoring. So before AWS or IAM, passwords were often shared in a corporate environment in a very insecure manner, over the phone or through the email. Often only one admin password existed, which was commonly stored in a set location, or there was only one person who could reset it, and you needed to call the person to ask for the admin over the phone. So that was not secure at all, because anybody could walk by and eavesdrop and then walk away with the password and access to your system and have the uh, access to the sensitive information. So today we have a more secure communication tool, a third-party application called Slack, which is hosted on AWS. It helps people to share a document through the application so that eavesdropping is eliminated. So this is one of the examples. So having IAM gives you better control over your data storage, prevent unnecessary risky access, detect insider and external threats, and maintain data privacy compliance. Okay. Then there are 2 parts that we should be clear about. First, that IAM is not an identity store or an authorization system for your applications. The permissions that you assign are permissions to manipulate your AWS infrastructure, not permissions within your application. So if you are migrating an existing on-premises application that already has its own repository and authentication authorization mechanism, then that should continue to work when you deploy on AWS and is probably the right choice. So if your application identities are based on Active Directory, your on-premises Active Directory can be extended to the cloud to continue to fill that need. So a great solution for using your Active Directory in the cloud is AWS Directory Service, which is an Active Directory compatible directory service that can work on its own or integrate with your on-premises Active Directory. Okay, so finally, if you are working with a mobile app, consider Amazon Cognito for identity management for mobile applications. Second point is that IAM is not operating system identity management. So remember that under the shared responsibility model, you are in control of your operating system console and configuration. So whatever mechanism you currently use to control access to your server infrastructure will continue to work on your Amazon EC2 instances, whether that is managing individual machine login accounts or a directory service such as Active Directory or LDAP. So you can run an Active Directory on an LDAP server on Amazon EC2, or you can extend your on-premises system into the cloud. Okay. Then AWS Directory Service will work well to provide Active Directory functionality in the cloud as a service, whether standalone or integrated with your existing Active Directory. Okay, so IAM is controlled like most other AWS cloud services through AWS Management Console, like other services. Okay, AWS Management Console is the easiest way to start learning about and manipulating a service. And then you have the second option with the CLI. So as you learn the system, you can start scripting repeated tasks using the CLI. And then you have AWS SDKs. So eventually you may start writing your own tools and complex processes by manipulating IAM directly to the REST APIs via one of the several SDKs available. So all of these methods would work to control IAM just as they work with other services. In addition, the Amazon Partner Network, AWS Partner Network, includes a rich ecosystem of tools to manage and extend IAM. Okay. Then there are some additional benefits like location flexibility, encouraging integration, and competitive advantage. Okay. So these are the additional benefits that you get in using your IAM. So like I described in the last slide, so IAM is a web service which is available in the portal that you can browse through for securely controlling access to your AWS resources. It will help you create and control services for user authentication or limit access to certain set of people who use your AWS resources. Okay. For example, let's say if you have various members in your team who have different roles and responsibilities, okay, and then you want to effectively manage them, okay, and have the delegated and have your access delegated basis on their day-to-day work. For example, let's say if I have a person who manages the storage currently on my AWS environment, and he also used to manage the storage on my data center. Okay. So I can simply create a specific role that grants him access to that respective resource only. Okay. So he will have access only to the S3 buckets, okay, in which the storage is there, in which the data is there. And other than that, he won't be able to access any other thing. Okay. Then you have other parameters, like if a person who manages your EC2 instances, okay, and you want only that person to manage only the machines and not any other service on the portal. You can have a specific role created for that respective user. Okay. So there can be n number of use cases that you can define basis on the roles and responsibilities of the user and have it implemented in your AWS environment. Okay. So if I talk about the use cases, we have fine-grained access control to the AWS resources, just like I mentioned. Okay, basis on the resource, like let's say if there is a developer who wants to write code in your AWS Lambda function, okay, or he needs to use that Lambda function for integration between two application components. Okay, then you will grant simply the access to that respective person to control that resource or administer that resource. Okay. Then second would be having your multi-factor authentication for highly privileged users. Let's say if there is an administrator, okay, who wants to access that respective application. Okay, so administrator credentials are very important. If they get compromised, okay, then your environment can be under any kind of a malicious attack. Okay, so in order to avoid such scenarios, in our IAM, we can enable multi-factor authentication as well for your administrators who are having access to sensitive data. Okay, so such things can be controlled in your AWS environment, and you should take this as a part of your cloud foundation strategy. So when I say cloud foundation strategy, from the day one, you should be having only the granted the only the required access to the respective teams. Because if you start building up your foundation, your environment, and then later on grant access to various people, so it may create some issues, okay, from technical perspective, that they are unable to deploy a machine, or they are unable to create an S3 bucket, okay, or when they are creating a machine, they are not able to associate a network interface card to that respective EC2 instance. So such issues will come up. Okay, so right at the day one, okay, it is advisable. There is no harm even if you are deploying it at a later stage after you have deployment. But yes, it is provided and a best practice that AWS asks all to follow. Okay. Then you can analyze the access as well. Okay, when I say analyze the access, so whosoever has access, so there are activity logs that get generated. Okay, so using your IAM, it would be helpful for you to track all these people who have accessed respective resources or done any kind of a modification in that respective resource. Okay, so using this, you can simply track your AWS infrastructure. Okay. Then you can integrate with your corporate directory. Let's say if you are using your Active Directory, you can seamlessly integrate your Active Directory with the AWS directory service that's there, so that when the identities are synchronized, okay, you have one identity that can be managed in both the worlds. Okay, so this helps you, gives the flexibility, having single identities that can be effectively managed. Okay, and then those Active Directory identities will also be used for your application authentication and authorization as well. Let's say if you are using any PaaS service of your AWS, okay, any PaaS offering, okay, then it gives you the benefit of using the same identity to have that authentication and authorization to be done with that respective application. Okay, so having your IAM set up gives you many leverages in order to use this particular application. Okay. Then how does your IAM work? So let's say you have an account ID. Okay, you have your AWS account ID. So there is a principal that you create. Your principal can be your user or a role that you define, a federated user or an application that is registered. Okay, let's say there is a PaaS application that is registered, will act as your principal. Okay, then it will simply see what all resources access has been granted. Okay, it will authenticate, it will request for the action for the resource to whether it has to modify it, create it, or delete it. Okay, so basis on that, it will simply try to access that particular resource. So once the principal raises a request, okay, it will simply check for the policies that has been applied, the authorization. Okay, so in the next box that you see over here in the authorization box, you see there are identity-based policies, other policy, and resource-based policy. So identity-based policy means policies that are applied to a respective user. Okay. For example, let's say you have an Active Directory administrator, okay, who is your IAM administrator, okay, then the person responsible for managing it has a certain level of access to few services. So he will be only be able to monitor and administer only Active Directory related components. Okay, so that identity will have its own life cycle at the time of assignation and creation. When you define that particular or grant that access to that respective user, okay, it will have an identity based policy. Then there can be other policies, okay, which you can customize it. Let's say if you want a person to manage the SQL database, okay, let's say there is a SQL server running in your AWS environment, okay, and you define the action, the effect, the resource, and the condition. If it matches, the person will be granted access. If it does not matches, the person will not be simply granted the access. Okay. Then we have your resource-based policies. Okay, so in the resource-based policies, we have our effect, action, principle, and condition, just like we do for our identity and other policies. However, the only difference is we have defined the policies, let's say, basis on the EC2 instances. Okay, so for EC2 instances, person who has access will be having certain set of authorizations to be performed. Other than that, he will not be able to perform. Let's say a person will not be able to delete a virtual machine, okay, or an EC2 instance that's there, or a person will not be able to delete or modify the S3 bucket. Okay, so those kind of policies can be created basis on the resource. Then we can define the actions or the operations using the console or the CLI or any API. Okay, like we can define it for our EC2 service. Okay, that whether the person is authorized to run the instance, start or stop the instance, whatever actions that have been defined in our authorization. Okay, if that matches, then those actions will be performed. If it does not matches, it will simply deny and give a message that you do not have the authorized access to run this particular instance or modify this particular instance. Okay, then we have IAM service, okay, in which you can simply create a user, delete a user, or simply get some properties or view the properties of the user. Okay, then let's say if a person who has authorization for the S3 service, okay, what all tasks he can do, whether he can create a bucket, delete a bucket, or list all the S3 buckets. So it totally depends what you have applied in the above authorization defined in the authorization policies. Okay, then comes your resources. Okay, so the actual resources on which these policies will be defined. Okay, once the authorization has been checked, okay, and the actions that has that a person has to perform on the resources, then the person can simply define, okay, I can simply access my EC2 service, okay, associate volumes, create security groups, create instances. Similarly, for my IAM, I can create groups, define roles, and create users as well, add membership to a role. Okay, then similarly for my S3 service, I can have my buckets, objects being created. Okay, so at a high level, this is how your IAM will work. Okay, as soon as the user request, all these workflows get triggered. Okay, and once these workflows are completed, then the access is granted to a respective user. Now let's talk about the various components of the IAM. We have four major components, which are your users, groups, policies, and roles. Okay, so in our users, it comprises of all the administration teams that are there, the people who are managing your resources. Okay, so all those become a part of your users. Then you can have groups created as well. Let's say you can create a group of your IT administration team who has the entire read-only access. Okay, so such customized groups can be created in AWS, which will help us to effectively delegate the access, do the administration tasks on the required resource, and help in overall compliance, meeting the overall compliance and governance, so that the unnecessary people are avoided when we or unnecessary malicious attacks are avoided when we have only the required persons defined over here. Okay, so groups would be beneficial for us in this particular scenario. Then we have our policies. Okay, so when we talk about policies, there are various policies that can be created. Okay, like what all resources can be provisioned. Okay, let's say in EC2 instances, what size of machine can be provisioned across my environment. So such policy, for example, for EC2 we can create. Similarly, for our S3 bucket we can create as well. Okay, that who will be authorized to create which type of S3 bucket. Okay. Then if I talk about any other service, like which all services are overall allowed in my AWS account that can be provisioned. Okay, so we can simply exclude certain services that are simply not required by an organization. Because let's say in any public cloud, if I talk about right now over here about AWS, there are plenty of services that we can choose from. Okay, and we would not want that we simply delegate the access to all the services, because each and every service is having some cost associated with it, and we want to take care of the cost, because we don't want a bill that simply shocks the customer that, oh, like I had a user accidentally created one of the service, okay, and it costed them like a bomb. Okay, so in order to avoid such situations, you can create a policy in which you mention that what all sources can be created or provisioned in your AWS account. Okay, then comes your roles. So you can simply define various set of roles in your AWS. Like I described earlier, you can have your virtual machine contributor, you can have your network contributor, you can have your backup uh, roles that are basically responsible for managing the overall infrastructure. So you can define the roles as per your organization IT team structure. Okay. So these are the four basic components of IAM. Just give me a second here. I think my slide got stuck. So in the meantime, I think my slide comes back. Okay, so if I talk about the roles and the temporary security tokens, we can have a number of use cases. Like we can have Amazon EC2 roles, in which we grant the permissions to the applications running on Amazon EC2 instance. Then we can have cross-account access, like granting permission to users from other AWS accounts, whether you control those accounts or not. Then we can have federation enabled. Okay, so granting permission to use authenticated by a trusted external system. Okay, so we can have such roles created. Then if I talk about the AWS principles, okay, in the principles, we have basically three types. One is our root user, okay, who cannot be limited and is a permanent one. The root user will have the access to the overall environment. Then we have our IAM users, okay, which are access controlled by policy, durable, and can be removed by the IAM administrator. And the third principle is your roles or temporary security token. So which access is controlled by policy, temporary expire after specific time interval. So there are three ways that IAM authenticates a principal. First is the username or password, using that. Second is your access key, which is a combination of an access key ID and an access secret key. So when a program is manipulating the AWS infrastructure via the API, it will simply use these values to sign the underlying REST calls to the service. Then third is access key or session token. So when a process operates under an assumed role, the temporary security token provides an access key for authentication. Okay. So here are some of the main features of IAM, like you can have a shared access to the AWS account, granular permissions are there, you can enable multi-factor authentication, identity federation. Okay, so when I say federation, that means like many organizations already have an identity repository outside of AWS and would rather leverage that repository than create a new and largely duplicate repository of IAM users. Similarly, web applications may want to leverage web-based identities such as Facebook, Google, or login with Amazon. So IAM identity providers provide the ability to federate these outside identities with IAM and assign privileges to those users authenticated outside of IAM. So IAM can integrate with two different types of outside identity providers. Okay, for federating web identities such as Facebook, Google, or login with Amazon, IAM supports integration via the OpenID Connect, okay, OIDC. So this allows IAM to grant privileges to users authenticated with some of the major web-based IDPs. For federating internal identities such as Active Directory or LDAP, IAM supports integration via the Security Assertion Markup Language or SAML 2.0. So a SAML compliant IDP such as Active Directory Federation Service is used to federate the internal directory to the IAM. So in each case, federation works by returning a temporary token associated with the role to the IDP for the authenticated identity to use for calls to the AWS API. Okay. Then IAM is free to use. Okay. It is a PCI DSS compliant as well. And you can also define the password policies as per your organization. Okay. So before establishing IAM, let's see. So rushing into an IAM implementation will often cause more headaches than it will solve. So that's why it's so important to plan ahead and set a clear strategy for how IAM will be run within your organization. So you can define the IAM implementation team and determine what individuals and teams will have which responsibilities in the process. So although IAM tasks usually fall to the IT groups, make sure to have stakeholders involved from across the organization. Okay, like let's say you should have your application team, your security team, your network team, your core data center administration team. Okay, and then you have all the managers that are managing all these various technology pillars. So everything, all the teams should be involved when you are making a call on the identity and access management. Okay. The third thing is you have to consider various IAM solutions from different vendors and put together a package that suits your needs best. Okay, so there are various solutions that are out there. Okay, you can integrate those solutions with your IAM offering. Okay, with the AWS IAM offering. Okay, or if you want to simply go for the native IAM that AWS offers, you can go for that as well, like going with the AWS identities. So it totally depends on how you want to go ahead with. Then you can perform a survey of your organization that captures information about every unique human being and technology resource, including hardware, software, and networking systems. So a tool like Veronis data classification engine can help to automate this process. Okay. Then in order to implement identity and access management, so depending on what IAM solution you choose, implementation can take up to several weeks to complete. So make sure your resources have the bandwidth to focus on these tasks without being distracted by other issues. So first, you can set up automated user feeds that will import data from your HR or personnel repositories so that your IAM system always has the latest information and records. So you can mimic your organizational structure in your IAM role policies and ensure you are following the principle of the least privilege. Okay. Then you can turn on multi-factor authentication for your high-profile users, okay, who are having access to sensitive data and resources that contain sensitive uh, business information. Okay, so this activity is part of your privileged access management. Okay, then there are other key features that you should think about, like rotating the keys. So security risk of any credential increases with age of the credential. So to this end, it is a security best practice to rotate the access keys associated with your IAM users. So IAM facilitates this process by allowing two active access keys at a time. So the process to rotate the keys can be conducted via the console, CLI, or SDK. So what you need to do is you need to create a new access key for the user, reconfigure all the applications to use the new access key, disable the original access key, okay? Then verify the operations of all the applications and then delete the original access key. So access keys should be rotated on a regular basis, okay? And then if I talk about MFA, it is also a good option because it adds an extra layer of security to your infrastructure by adding a second method of authentication by just a password or access key. Okay. So MFA can be assigned to any IAM user account, whether the account represents a person or application. So when a person using an IAM user configured with MFA attempts to access the AWS management console, after providing the password, they will be prompted to enter the current code displayed on their MFA device before being granted the access. So an application using an IAM user configured with MFA must query the application user to provide the current code, which the applications will then pass to the API. So it is strongly recommended that AWS customers add MFA protection to their root users, okay, because that is the most critical user. Then let's see how to create a IAM policy. So in order to create your IAM policy, first you need to decide the resource, like you can define an AWS Lambda function in which you define the role, the AWS IAM role. Okay, so AWS IAM role over here will have the various authorizations that it can perform. Okay, so let's say this can modify a AWS Lambda function. It can simply, let's say, deploy a new Lambda function, but not delete a function. Okay, so this can be one example of your IAM policy. Okay, similarly, you can have these policies created for your various set of services that are there across the AWS. Okay, then whenever we are using this AWS IAM policies, okay, these authentication and authorization, whenever it is happening, where it is checking whether it has the required access or not, or when a user access that policy, that respective resource or not, that will be logged into the CloudWatch. Okay, so which will contain all the activity logs that are happening across your AWS environment. Okay, so you get that flexibility. So basis on the requirement of the role, you can simply specify who will have access of what, okay, and what are the responsibilities of that person. Basis on that, you can decide that what all tasks can be done. Okay. Then you can also create temporary roles as well. Let's say if a person requires a role for a or for an duration, let's say for 15 minutes, varying up to 36 hours. So you can create a temporary security token as well. So they are very important for advanced IAM usage, but many AWS users find them confusing. So roles are used to grant specific privileges to specific actors for a set duration of time. So these actors can be authenticated by AWS or some trusted external system. So when one of these actors assumes a role, AWS provides the actor with a temporary security token from the AWS STS, which is your AWS Security Token Service, that the actor can use to access. Okay, so requesting a temporary security token requires specify how long the token will exist before it expires. So there are certain roles and temporary security tokens that enable a number of use cases that can be enabled on a number of use cases. Like for your Amazon EC2 roles, you can grant permissions to applications running on an Amazon EC2 instance. Then you can have cross-account access, which grants permission to users from other AWS accounts, whether you control those accounts or not. And then federation as well. So granting permission to users authenticated by a trusted external system. Just give me a second here. Then coming back to one of the slides that I just showcased, okay, wherein we were walked through the various workflow, okay. So in this particular workflow, we saw that there are three ways that the IAM authenticates a principal. First is by using a username or a password. Second was using the access key. Okay, and third was using an access key or a session token. So when I say username or password, so when a principal represents a human interacting with the console, the human will provide a username or a password pair to verify their identity. So IAM will simply allow you to create a password policy enforcing password complexity and expiration. Then second, you will have the access key. So access key is a combination of an access key ID, which is of 20 characters, and an access secret key, which is of up to 40 characters. So when a program is manipulating the AWS infrastructure via the API, it will use these values to sign the underlying REST calls to these services. So the AWS SDKs and tools handle all the intricacies of signing the REST calls. So using an access key will almost always be a matter of providing the values to the SDK or tool. Then we have access key or session tokens. So when a process operates under an assumed role, the temporary security token provides an access key for authentication. So in addition to the access keys, the token also includes a session token. So calls to the AWS must include both the two-part access key and the session token to authenticate. So it is important to note that when an IAM user is created, it has neither an access key nor a password, and the IAM administrator can set up either or both. So this adds an extra layer of security in that console where users cannot use the credentials to run a program that accesses your AWS infrastructure. Okay, so if I draw the workflow, let me just open a whiteboard. So let's say this is my user over here. Okay, so this user simply tries to access an AWS account, okay, by providing his or her username or a password. Okay, so user will authenticate to the AWS console with their user account. Okay, then the access key ID and the secret key will be checked. Okay, So whether this identity has access to the required resource that it is trying, let's say it's an S3 bucket. Okay, so application authenticating to the AWS API with IAM user account. Okay, then in the third step, the user or the application using temporary security token, okay, will be having the access to the required resource. Then this person will be granted the resource after checking the access key ID and the access secret key. Okay, then basis on that, this user will check, will have the details of the access key ID. Okay, it will have the secret key as well. Then it will have a session ID as well. Then when these three are matches, then the resource will be having the access on the AWS account and the particular resource, let's say, as we take an example of an S3 bucket. Okay. Then if I talk about the authorization, so after the IAM has authenticated a principal, it must then manage the access of that principal to protect your AWS infrastructure. So the process of specifying exactly what actions a principal can and cannot perform is called your authorization. So authorization is handled in IAM by defining specific privileges in policies and associating those policies with principals. Okay. So if I talk about the policies, understanding how the access management works under IAM begins with the understanding of the policy. So policy is a JSON document, okay, that fully defines a set of permissions to access and manipulate AWS resources. Okay, let me just switch my screen. Give me a second here. Let me just close this whiteboard. Okay, so I'm back to my slide. So if I talk about the policies, okay, which are there, which are your JSON files that I had talked about. So I'm just going in a bit more detail now over here. Okay, so I just saw a question that who will be responsible for writing these policies. So the person you dedicate in your team, okay, will be writing all these policies. Okay, so understanding how the access management policies work under the IAM begins with understanding these policies that you write. So policy will be your JSON document that fully defines the set of permissions to access and manipulate the AWS resources. Okay, so it has an effect which will be a single word, okay, that is over here, which will simply tell you allow or deny. That's it. Then you have your service, which will define for what service does this permission apply. So most AWS cloud service support granting access through IAM, including IAM itself. Then you need to specify the resource. The resource value specifies the specific AWS infrastructure for which this permission applies. So this is specified as an Amazon resource name. So the format for an ARN varies slightly between services, but the basic format is like ARN colon AWS colon service with followed by a region account. Okay, and then the resource. So for some services, wildcard values are allowed. For instance, an Amazon S3 ARN could have a resource of folder name followed by an asterisk. That means for all the buckets. That means all the objects in the specified folder will be allowed. Okay. So let me just write a sample ARN on the whiteboard, which will give you much better understanding. So an ARN would somewhat look like, let's say for an S3 bucket, how the ARN would look like. It will be ARN, then there will be a colon. Sorry for the typo. Let me just, okay. Then followed by AWS, then followed by the service, that is our S3, then followed by the location, let's say it's US East 1, followed by some account, your AWS account, let's say it's 1, 2, 3, 4, 5, 6, 7, 8, followed by your name of the bucket, let's say it's my underscore bucket, just an hypothetical name. And then there would be, let's say I put an asterisk over here. That means all the files that are under this my bucket will be having access, okay, that I specify. Similarly for your IAM user, you will have, and similarly for your, let's say a DynamoDB table, okay, this will be written. So you can associate policies with principals. So there are several ways to associate a policy with an IAM user. Okay, so it can be associated directly with an IAM user in one of the two ways. One is your user policy. Okay. And second is your managed policies. Okay. So in the user policies, these policies exist only in the context of the user to which they are attached. Okay. So in the console, a user policy is entered into the user interface on the IAM user page. Then we have managed policies. So these policies are created in the policies tab on the IAM page through the CLI, okay, and exist independently of any individual users. So in this way, the same policy can be associated with many users or groups of users. So there are a large number of predefined managed policies that you can review on the policies tab of the IAM page in the AWS Management Console. Okay. Then if I talk about the other common method for associating policies with the users is with IAM groups feature. So groups simplify managing permissions for large number of users. So after a policy is assigned to a group, any user who is a member of that group assumes that those permissions. So this makes it simpler to assign policies to an entire team in your organization. For instance, if you create an operations group with every IAM user for your operations team assigned to that group, then it is a simple matter to associate the needed permissions to the group. And all of the team's IAM users will assume those permissions. So new IAM users can then be assigned directly to that respective group. So this is a much simpler management process than having to review what policies a new IAM user for the operations team should receive and manually add those policies to the user. So there are two ways a policy can be associated with an IAM group. Okay. First is your group policy. Okay. And second is your managed policy. So your group policy, these policies exist only in the context of the group to which they are attached. So in the AWS Management Console, a group policy is entered into the user interface of on the IAM group page. Okay. Then managed policies in the same way that managed policies like can be associated with the IAM users, okay, and they can also be associated with the IAM groups, okay. So there are different ways that policies can be associated with an IAM user, okay. For example, let me just clear this whiteboard. Let's say I have user A over here, okay, then I have a user B, okay, then I have, let's say, C over here. Now I have created IAM groups as well over here, okay. This is my IAM group. Let's say it's my IAM group 1. Then I have my other IAM group as well. Let's say it's 2, okay, and then I have my policies created, okay, for this particular IAM group as well. Like I have one policy over here which defines something. Then I have another policy that defines something else. Similarly, this has separate policy altogether, which also has some definition associated with it. So what I can do is I can associate, let's say, user B and C to this particular user group, and user A is part of this group, okay. So this way we can associate IAM users with policies. So a good first step is to use your root user to create an IAM policy called IAM administrator and assign the managed policy. That is your IAM full access. Then create a new IAM user called administrator and assign a password and add it to the IAM administrator groups. So at this point, you can log off as the root user and perform all the further administration with the IAM user account. Then the final way an actor can be associated with the policy is by assuming a role. So in this case, the actor can be an authenticated IAM user. Okay, so in this case, IAM user must have the rights to assume the role. Then second is a person or process is authenticated by a trusted service outside of AWS, such as an on-premises LDAP directory or a web authentication process. So in this situation, an AWS cloud service will assume the role on the actor's behalf and return a token to the actor. So after an actor has assumed a role, it is provided with a temporary security token associated with the policies of that respective role. So the token contains all the information required to authenticate API calls. This information includes a standard access key plus an additional session token required for authenticating the calls under an assumed role. Okay. Now going back to the slide. So if we conclude about what we learned today, okay, so IAM is a powerful service that gives you the ability to control which people and applications can access your AWS account at a very granular level. So because the root user in an AWS account cannot be limited, you should set up IAM users and temporary security tokens for your people and processes to interact with AWS. So policies define what actions can and cannot be taken, and policies are associated with the IAM users either directly or through group memberships. Okay, so a temporary security token is associated with the policy by assuming an IAM role, and you can write your own policies or use one of the managed policies provided by AWS. So common use cases for IAM roles include federating identities from external IDPs like Google, Facebook, LinkedIn, or an Amazon account, and assign the privileges to an Amazon EC2 instance where they can be assumed by applications running on the instance and cross-account access. Then IAM user accounts can be further secured by rotating the keys like we discussed. Okay. Implement MFA, okay, and add conditions to the policies. So MFA ensures that authentication is based on something you have in addition. Okay, and conditions can add further restrictions such as limiting client IP address ranges or setting a particular time interval.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.